This is the fourth in a series of educational videos to help you maintain the best performance from your Agilent ICP MS. Let's turn our attention to the interface region, which includes the sampler and skimmer cones, the extraction lenses, and the 4-line pump. First, we will look at the sampler and skimmer cones. Dirty, blocked, or damaged interface cones adversely affect the sensitivity, precision, and background of your analysis. Both the sampler and skimmer cones should be regularly inspected, paying close attention to the condition of the orifice. Gradual changes in the vacuum level of the interface region is also an indicator for cone maintenance. To clean, first remove the sampler cone and then the skimmer cone using the tool provided. Take care not to damage the cones. They are delicate and should be handled with extreme care. Remember, ensure the tips do not come into contact with any other surface. Only handle the cones by their outer edges. For routine cleaning of the cones, a simple water clean is all that is required. Clean both sides of the cone by wiping with a cotton swab dipped in pure deionized water. Rinse with deionized water. Place the cone in its own beaker with the tip pointing upwards. Finally, sonicate for at least 5 minutes, again in deionized water. If cleaning in deionized water has not cleared the orifice of the cone, a more thorough clean will be required. Sonicate the cones in a 2% Citrinox solution for 2 to 3 minutes. Rinse the cones immediately with deionized water. Finally, sonicate in deionized water for at least 5 minutes. If performance is still not satisfactory after reinstalling and testing the cones, clean both sides of the cone by wiping with a cotton swab dipped in 2% nitric acid. Rinse with deionized water and sonicate for 2 to 3 minutes, again in deionized water. Repeat the deionized water rinse and sonicate for a further 2 to 3 minutes in fresh deionized water. If performance is still not acceptable after following these cleaning steps, refer to your maintenance video for a last resort cleaning procedure using alumina paste. Remember, never soak the cones in acid. Excessive cleaning may reduce the lifetime and damage the orifice of the cone, and always thoroughly dry the cone before reinstallation. Another key component in the interface region is the extraction lenses. The extraction lenses are located directly behind and attached to the skimmer base. Cleaning or replacing the lens is only required after you have finished troubleshooting the sample introduction system and interface cones. You should only clean or replace if you observe more than 10% instrument drift per hour, or if you notice a slow response in the signal after changing the lens voltage manually or during tuning. For an immediate fix, you can replace the extraction lens assembly. Refer to your user manual and maintenance video guides for detailed removal, cleaning and replacement procedures. Make careful note of the equipment required before beginning. This includes polishing paper, alumina powder and an electrical circuit tester. Before refitting the cones, ensure they are dry. Align the skimmer cone with the two small tabs on the removal tool. With the cone in position on the tool, insert into the interface opening. Carefully rotate the tool clockwise until the cone is firmly tightened. Remove the tool. Always check the condition of the graphite gasket for the sample cone. Replace if damaged. Holding the sampler cone by its edges, place the cone in position and fit the retaining ring. Rotate this clockwise by hand until firmly tightened. Press the maintenance switch to return the torch box to its operating position. Check the interface and analyzer vacuum pressure readings. If these are higher than expected, you should suspect a vacuum leak. Remove the sampler cone and retighten the skimmer cone, then refit the sampler cone. After cleaning cones or installing new cones, conditioning is required before analysis. This aims to reduce instrument drift due to the initial deposition of sample matrix on the clean cone surface. Using robust plasma conditions, aspirate your sample matrix for 20 minutes and then aspirate your rinse solution for 10 minutes. If you run varying sample matrices, condition the cones by aspirating a 50 ppm calcium solution in 1% nitric acid for 10 minutes and then aspirate a 1% nitric acid rinse for a further 10 minutes. Here are some recommendations to help you maximize cone lifetime and ensure trouble-free operation. Choose the correct cone type for your application, then match it to the skimmer base. Nickel cones use a stainless steel skimmer base, and platinum cones use the brass base. Using the wrong skimmer base can overheat and damage the cone. Never try to clean a cone back to as new condition. Focus on the condition of the orifice and only clean when performance is unsatisfactory. If possible, visually inspect the cone orifice with at least 10 times magnification. Replace the cone if the orifice is enlarged, non-spherical, or shows any other damage such as discoloration, which may indicate overheating. Finally, let's turn our attention to the 4-line pump, which provides the interface chamber vacuum. Visually inspect the oil level and colour weekly. Top up the oil level as required. Always ensure the level is between the maximum and minimum indicators. Check that the vacuum hoses are securely attached and free from kinks. Typically, the pump oil should be changed every 6 months. When replacing the pump oil, check and replace the oil mist filter. These simple checks will ensure trouble-free pump operation. Thank you for watching. Please see the other videos in this series where we explore other critical aspects of your Agilent ICP MS and the maintenance tasks you should perform regularly in order to ensure your ICP MS always operates at its best.